Okay, good evening. This is the first lecture for Introduction to Chemistry. So this is I'm just gonna throw a bunch of stuff at you, and this is just to get you introduced to chemistry if you're a beginner at it, and you don't have to worry if it doesn't make too much sense to you right now. I just want to give you some concepts. So this is the first lecture. So let's go ahead and begin right now. So first of all, matter is well, I want to go over some definitions, and the first one is matter, which is composed of atoms, right? And matter has mass and takes up space. So we will talk more about atoms in other lectures, but right now it's just throwing stuff at you, getting you introduced. So atoms are minuscule, meaning they are, well, very small, right? And atoms determine how matters behave. So going back to the atoms are minuscule part, to put this into perspective, a single grain of sand has more atoms than a beach has individual grains of sand. So just picture that in your mind for a second. Like, pick up a grain of sand. That small grain of sand has more atoms than all of the individual grains of sand at a beach. So that just is for something for you to think about to keep a perspective of how minuscule or small atoms really are. So yeah, continuing, atoms determine how matter behaves. So we got atoms, and atoms make up molecules, right? We'll talk more about this later. Right now I'm just like building a frame for you. So atoms make up molecules. Molecules make up matter, right? And so yeah, atoms and molecules, since atoms make up molecules and molecules make up matter, and atoms determine how matter behaves, atoms and molecules, they determine behavior. They determine behavior, and behavior also is going to determine the properties. And we'll see that in an example. So we need to understand this, right? We need to understand that atoms and molecules, how they are important in order to understand this, right? So let's go ahead and see an example. Water molecule, we got the formula, which is H2O. And let us draw a water molecule. So, since we were talking about atoms and molecules, a water molecule has 3 atoms, right? We got the 2 hydrogens, and we have the oxygen. And the angle between them. So if you were to get like a really microscopic protractor and just like put it right here, the angle between them will be roughly, would be roughly 105 degrees. And this is bent geometry. And bent, I mean this. Notice how this geometry is bent. It is not straight. It's bent like that. So not linear. So it's not that, right? And you will learn about geometry later on. This is just for now. I want you to know that water has a bent geometry. And you might see others draw water like this. Don't do that. Get into the habit of drawing it bent, like I drew it here. So I want you to get into the habit early on to draw water like that. So yeah, we're gonna learn more about that when we talk about more of electronegativity. So the oxygen atom causes the bent shape because it is more electronegative than the H's, than the hydrogens. So this pulls electron density towards it. Right? So let us draw it again and see what I mean by that. So here's your water again. Let's see how much space I have. Okay. So that's your water. And we're going to have a partial negative charge on the oxygen, partial positive on the hydrogens, and then we're going to have this. Those arrows are called dipole moments, right? So the H's are partial positive. Yeah, the O is partial negative. And these Greek letters are called delta, and they are used to represent the partial charges. So the reason why we call them partial is because they don't have a full negative or positive charge. Since electrons are negative, the O, which is more electronegative, is going to pull electron density towards it. Therefore, there's going to be a higher concentration of negative electron density at the oxygen, therefore making it more partial negative. And the hydrogens are going to have a less concentration of electron density, making them partial positive. So it's just partial charges. They're not full charges. We'll talk more about that later on. So it's okay if it doesn't make sense. This is just a visual example. Okay. So yeah. So O has, well, oxygen has more. The oxygen atom has more negative density than the hydrogens. Okay. So basically kind of what I just said. Let's move on. So let's go ahead and see some bonding. Another, to add to this example, let us redraw again our water molecule. Let us draw another one right here. Oh yeah, by the way, oxygen is also bigger than hydrogen, and it's also heavier. Just a fun fact. So the hydrogen is going to have a partial positive, how we explained earlier. The oxygen is going to have a partial negative. And these two are going to basically form a bond. And yeah, this bond is going to be called a hydrogen bond. So hydrogen bonding. which you will see plenty of as you continue taking chemistry classes. So you'll see a lot of this. So it's best to get you familiarized with it now, so we can like have a framework in your mind to get familiarized with this. Okay, so this is so hydrogen bonding, right? They typically have higher boiling points. And this is what we would call a physical property. So as we can see here, this is the behavior of atoms. Just like how we were speaking about it in the beginning. This is because a hydrogen and an oxygen are interacting together to form a hydrogen bond, which in turn gives us a compound with a more of a stronger bond, which will give us a higher boiling point. So as you go along and you see compounds that can form hydrogen bonds versus compounds that cannot form hydrogen bonds, compounds that can form hydrogen bonds are going to have a typical higher boiling point than the ones who don't. And you'll see more of that as you go along. So for now, just keep that in mind. So yeah, I mean, here we see how a partial positive H interacts with a partial negative O atom to form a hydrogen bond, like I said. So this behavior determines physical properties like higher boiling points, just like we went over. And then hydrogen bonding typically gives a matter I already said that. Gives a matter a higher boiling point, right? So it's a stronger bond. And this is just a visual example for you to like learn about the different bonds later on, right? This is just to get you familiarized. So let's go ahead and add on to this. I don't have that much space, but that's okay. So let's add on to the squiggly line to separate it. So this is a water molecule. Sorry, those are my cats. Anyways, that's a water molecule. H2O, water. And then we have hydroxide. And that is, that's hydroxide, OH minus. Let me just, this is hydroxide. So these here are different substances. They have different behaviors. And different physical properties. Let's just say properties, because they also have different chemical properties. So this is just another example. If we take away a hydrogen atom from the water, you'll get hydroxide, which is different from water, right? So you can drink water, but don't drink hydroxide because it can cause chemical burns, and water typically does not cause chemical burns, so you can actually see the difference there. So this is just to show you how atoms determine behavior of matter. So water and hydroxide have two different behaviors, and just you can see that if we just take away one hydrogen atom from water, it's going to be hydroxide, and that is a corrosive substance. So that's just another example to show you the importance of atoms and how they influence behavior and properties, right? So let's continue. So overall, chemistry is a study of behavior of atoms and molecules to understand behavior and properties of matter and how matter changes, right? So molecules compose chemicals, right? So yeah, that's a simple definition for like the purposes of introductory chemistry. So let's talk about chemicals. Chemicals, basically anything you can touch is made out of chemicals. Chemicals make up these things, right? So let's see. So yeah, matter is made out of chemicals. Matter is made of chemicals. And air, these are just examples. Air is also made of chemicals. So yeah, you can touch air, right? So let's look at stuff that is not made out of chemicals. So heat and light, they are not chemicals, and they are also not made out of chemicals. So heat is just a movement of thermal energy, and light is made out of photons, not chemicals. So if you can't touch it, then it's not made out of chemicals. In short, molecules make up like your world, right? So let's look at some examples of chemical processes. Yeah. So these are just a couple examples. We're going to learn more about these when we look at the difference between physical properties and chemical properties, or physical changes and chemical changes. So this is the rusting of an iron nail. So basically, the oxygen, like the oxygen in our air interacts with iron over time, and this results in iron oxide. And this is a different compound. So that's a different compound. It's different from iron, from 100% pure iron, like we said that the nail was made out of. So that is how you know it's a chemical process. You get another like different substance, different compound in return. So that's how you know a chemical reaction has occurred. So let's look at another one. So the frying of an egg. So heat denatures proteins. So assuming this is your first chemistry course, I will assume that you don't really know what a protein, like the structure of it is. So just pretend you have a ball like of yarn, and it's all like this. And that is like a really simplified explanation of what a protein would be structured, right? So there's your protein, and you add heat to it. It's going to denaturize it. If you don't know what that means, it's just going to like break bonds and going to unravel the protein. So now it's like this, right? It's all like the bonds are broken, and now you have a different molecular structure. So yeah, they unravel, and this is a different molecular structure, and therefore different properties. Yeah, different properties, right? So you will learn more about this when you study the differences of chemical and physical changes, like I mentioned before. And these are just like some examples to really get you familiarized with what chemistry entails of. And I think, yeah, this is a good start. And if you want a copy to the notes so you can actually follow along, I mean, I should have said this in the beginning. Sorry about that. But if you want a copy to the notes, I will try and figure out how to put a PDF link in the description so you can like follow along if you want with the notes. You can download them and follow along. And if you have any questions, just let me know and I'll try my best to get back or answer them. And yeah, that's it. Good luck and thanks for watching.